so something a little harder. So this is the beginning of your problem. So I've written it as dy over dt, but truly it could have came at you like this, right? And so if it comes at you like this and you notice there's a t instead of an x, that's when you know that you need to use dy over dt, right? Okay, so the first step is to move it to the e term to the other side, because you do want to get to a point where you can cross multiply, correct? So this is another big deal. So see how you have e to the t plus y up in the exponent? So that's the same as saying e to the t times e to the y, right? So you know x to the a plus b is equal to x to the a times x to the b. You add exponents when you're multiplying, right? You know how to go this way. So now what we're doing is we're going this way, right? So if there's addition up here in the exponent, it's multiplication down here. Okay, so that's a necessary step. Now I'm going to multiply by dt. So I'm going to go slow. Okay, so I want to get t's on this side and y's on this side. So I'm going to divide through by y. Okay, so now I'm ready to integrate. Integrate. Okay, so this side's easy. E to the t plus c. How do you do this? Oh, yes, we just rewrite this as e to the negative y. Then it's an easy La Jolla theorem, right? In case someone's forgetting. E to the ax dx, that's 1 over a e to the ax, right? So my a is negative 1. So I'd get 1 over negative 1, which is negative e to the negative y. And I've got my c all stuffed into 1c over here, right? So now I'm going to multiply by negative. Okay, so negative c, I could put a negative c, or I could just say it's c, because negative c is just another constant, and I could call it c, or I could call it d. It doesn't really matter as I'm playing around with this stuff. So then I'm going to take the ln of both sides. When I have numbers in here, it matters, but when I'm just using a placeholder for c, it doesn't matter. So I'm going to take ln of both sides, so now be careful. So let me show you what would be wrong to do. To go in and say, oh, I'm going to take the ln of this thing, and I'm going to take the ln of this thing. That's really, really wrong. You cannot go and take the ln of each term individually like that. So that is incorrect. Okay, so I'm going to erase that because you've written it down, and you're never going to do that. So you're going to take the ln of both sides. So I get negative y is ln of, and then I'm going to take the negative. So y equal negative ln. And there it is. So this is the function, this functions that when you take the derivative of it, it solves this differential equation. Okay. So here we are. Now we're going to have information. So we call this an initial condition, where we're going to we'll be able to find what the c is at the end of the problem. Okay, so this one here has t's. So that's why I know my first step is going to be rewriting y prime as dy over dt. Okay, multiply by dt. And I think it's all set, right? Ready to integrate. All right, so this turns into y squared over 2. 2's cancel. This over here. Oh, you see it? It's going to be parts. So if you've done enough parts that you even recognize it, right? V is e to the t. So uv. Whoops, I got the equal sign already. Don't need it again now. So I have uv, so t e to the t minus integral of v du. So finishing it off, t e to the t minus e to the t plus c. Okay, so I'm reminding myself that this is an initial condition problem. So at this point right here, before you go finishing off solving for the y, right, because to solve for the y, we're going to have the square root. Before you finish solving for y, as soon as you get the c down and all integrals are gone, this is the easiest place to solve for c. All right, so I'm going to put the y is 1, right? That's what this means. Y is 1. And this means put in t is 0. So this gives me 0, e to the 0, And then I've solved for c, so be careful. So that's 2, right? 2 is c. Okay, so now I'm going to plug that back into here. So I get y squared is t e to the t minus e to the t plus 2. Now finish solving off for y. So I get y is equal to plus or minus the square root. Okay, so one other little point. So this is the function that solves the differential equation with this initial condition. Okay, so to satisfy this initial condition, this says when y is 1, t is 0, right? It works. So if y is 1, doesn't that mean this has to be the positive, right? Has to be the positive. So I don't need to have the plus minus. So at the end, I can kind of just consider, is there a root? Do I have enough information to decide that it's the positive root? I do. And so I don't need to write the positive sign. I just write nothing, right? I just get rid of the plus minus.